Hey class, today we're going to start talking about polynomials. Poly means more than one term, more than one term. So let's just start off by talking about one term. So if we have one term, then what we have is a monomial. So here are three examples of monomials. Notice in each term, there's no adding or subtracting. That is key. There's only multiplication. Okay, so we have a coefficient, we have a variable, we have an exponent. The coefficient on this one would be the 1, the variable, and the exponent in this case would be a 1. Coefficient, variable, exponent, variable, exponent. So these are examples of a monomial. There's no adding or subtracting involved. Okay, so let's go ahead and dive into what is a polynomial. So polynomial is going to be um, multiple terms. So you'll be combining monomials by adding or subtracting them. So here are some examples. Here we have two monomials that have been added. And since we have an addition here, we now have a polynomial of two terms. Here we have three monomials being added and subtracted. And since we have three of them, that's more than one. That makes a polynomial. And here we have two monomials being subtracted. So this is a polynomial. So whenever you're adding or subtracting monomials, you begin to form a polynomial. Okay, so let's go ahead and look at some examples here. One term, again, one term would be a monomial. For example, 5x. That would be a monomial, one term. So if we had two terms, that would be like this example right here. And this is called a binomial. So for example, I'll just give a different, let's do a plus b squared. That would be a two terms or a binomial. Three terms, trinomial. The ones that we're used to seeing are the quadratic, terms. And so here we have three terms. Four-term polynomial, which is known as a quartic, I believe, or is it a quintic? No, I think it's quartic. Four-term polynomial might be might look something like that. Notice we have 1, 2, 3, 4 terms. And we have a five-term polynomial. That's 1, 2, 3, 4, 5. Five terms. Okay, so let's go ahead and look at some rules. So some rules. Exponents of a polynomial must be whole numbers. Exponents must be whole numbers, no negatives, decimals, fractions, or variables. Okay, so that leaves out exponential expressions. And the coefficients must be real numbers. Positives, negatives, decimals, and fractions are okay, but no imaginary numbers. Polynomials cannot have variables inside of absolute values or roots, and they cannot have terms that are being divided by a variable. So if you look below, these are all examples of expressions that look like polynomials, but they are not. Notice here, we have a variable in the denominator. Okay, that breaks one of the rules of a polynomial. They cannot have terms that are being divided by a variable. Cannot. Here we have a variable inside of a root, right here. Polynomials cannot have variables inside of roots. This is a square root. Here we have an exponent that is a decimal. It says here that the exponents must be whole numbers. And again, here we have a -3 exponent. That is not a whole number, okay? Okay, next let's take a look at the notes on adding and subtracting polynomials. Basically what we're doing is combining like terms. We're going to, first of all, this is your success criteria. You're going to distribute the plus or the minus sign between the polynomials to get rid of the parentheses if there are any. Combine like terms, and then write the polynomial in standard form. So let's go ahead and look at number 1, the first example. So basically, it says distribute the plus or the minus sign. So it's a plus sign. So if I distribute a plus sign to each term, they're going to stay the same. So we're going to have okay, so when you distribute a plus, these are all going to stay the same sign. Okay, combine like terms. So looking for like terms, so this first one, x cubed, x cubed, x cubed, no x cubes. So this one brings down. Always start with your largest exponent. Always start with the largest, okay? Then we have a positive 2x squared is going to combine with a positive 4x squared. That makes 6x squared. Negative 5x will combine with positive 2x to give us negative 3x. And then our constants, positive 7 minus 3 is going to be 4. And it says write the polynomial in standard form. And I made a mistake. This was to the third power. Okay, because it was to the third power here. Sorry about that. So when you're in standard form, we start with the highest exponent first, and then we descend. So 3, 2, 1, and the constant always goes on the end. So this is in standard form. We have 1, 2, 3, 4 terms in this answer. Okay, let's look at the next example. Step 1, distribute. So we're going to distribute the minus. So basically what that does is it changes all the signs. Okay, so we're going to bring down the first term. And then we're going to change the sign. So it's going to be minus 5x to the fourth plus 4x squared minus 6x plus 3. It's kind of like multiplying by -1, distributing -1 throughout this entire expression. Okay, so let's go ahead and combine like terms. So we're looking for the largest exponent. So that's going to be this -5x to the fourth. Since there are no other x to the fourth, that's going to be our first term. Okay, next largest exponent is a 3. There's no other 3's, so that one is going to go next. That's going to be our next term. And then 2's. 8x squared plus 4x squared is 12x squared. And then we're having 1x, and this is going to be minus 6x. That's going to give us -5x. And then 10 plus 3 is 13. Now when you combine them like that, you will automatically be in standard form when you finish. 1, 2, 3, 4, 5-term polynomial. Okay, let's take a look at this one. Here we have multiple groupings, so we have to distribute multiple signs. So this first term is going to stay the same. We're going to distribute that minus. Remember, when you distribute a minus, they change signs. Distributing another minus. And remember, when distributing a plus, they stay the same. Okay, so now we're going to look for the highest exponent. No other 3's. Next highest, x squared. Negative 3x squared plus 4x squared is going to be positive 1x squared. Then we have 2x minus x minus 1x, which is 1x. And then combining our constants, 4 minus 10 is negative 6. Negative 6 plus 6 is 0. So we do not have to put a 0 on the end. So here we have a 3-term polynomial. Finally, we're going to take a look at multiplying polynomials. So with multiplying, we want to multiply the terms of each polynomial using either distributing or the box method. Then we want to combine like terms, and then we're going to write in standard form. So this is basically review for us. So doing the distribution method, we would be distributing the 2x, the first term, times 4x minus 5. And that's going to give us, when we distribute that, it's going to give us 8x squared minus 10x. Okay, then distributing the 3 to 4x minus 5, we get 12x minus 15. So now that we've done the distributing, we are now going to combine like terms. So looking at it this way, we have the 8x squared first. And then combining these two, we have 12x minus 10x, which is 2x. And then the minus 15 on the end. So we have a 3-term polynomial as our answer. Okay, let's take a look at the box method. Two x plus 3 times 4x minus 5. So filling in the boxes, we multiply. So 4x times 2x. This is just a graphic organizer for doing distribution. Negative 5 times 2x. Negative 5 times 3. And then, of course, we do the combining of like terms. This term goes first. We combine these like terms. And the constant goes on the end. Same answer. All right, so now let's take a look at example 1. In this case, I'm going to just do one method with you, and I think the method I'll use here is a box. So I'm going to do a 2 terms by 3 terms. So 2x plus 4 on the side. All right, and I'm running out of time here. So I'm thinking that maybe I'll do a second video on these 3 examples for you that you can watch, because I have only 15 minutes with Screencast-O-Matic. So I tried to fit it all into one video for you. It's just not going to work. So I'll be back in a second video.